In this video, we are going to describe power functions. As the word power shows that something is raised to something else. In this, you can say that, and you can see that a function f of x is equal to x raised to the power of a, where a is our constant. So, any real number that raised to the power that represent a power function. As the graph shows that we have different graphs when we have a power of 1, we have to represent this graph of a straight line that shows that it's also a power function. And if you really don't write 1 over here, you can also assume that that 1 is already present in this. So next is the graph of our x raised to power 2, y is equal to x2. That is the graph of a parabola, and you can see that it is also a power function because 2 is raised to the variable x. And in this graph you can see that x is raised to the power of 3, and in this way it represents a function, a power function. And in the next example you can see that we have a function that power is 4, and it also shows the function that is power function, and it's a little bit bend flop position of x square, or you may say that parabola diagram. So in this next section we are going to draw a graph of x square, and by this you can easily get the idea how we can draw the graphs. Let me arrange it a bit. So now we will take all the values from the Cartesian coordinate and plot our points by using those points, by using that order pairs from here. Suppose I take a 0 in the x, and then you can say that we will get a 0 in y as well. This is our equation, that x raised to the power of 5. So the first point that we are going to plot is 0, and it lies over here in the origin. So our next point will be 1. Sorry. We have to put the value of x in this power function, and then we will get the value of y, that is also 1. And you can see that here lies our 1, a positive and axis of both y and x-axis, and here lies our point. So in the next, we are going to use the negative value of x-axis, that is -1, and we put the value over here to check the value of y. -1, -1, -1, and this point shows the multiplication sign, and you can see that by multiplying these both we will get a 1, positive 1, and when multiplying these two we'll get a positive 1 as well, and in the last we have a value that is -1. So by multiplying all these we will get the value of y, that is -1. So again we will plot our order pair in this graph, and you can see that here lies our -1 of the y-axis, and here lies our -1 of the x-axis, and here in, and next we are going to use positive value of x, that is 2, and then we will check the value of y by putting x in the x raised to power 5. You can use a calculator to check the value by multiplying 2 5 times. There is a problem in here, but we can see that by multiplying 2 we will get 5 times, we will get 32. So we can simply write it over here. And now we are going to plot our point. As you can see that 2 will be here, and 32 will be here in some. Suppose we are taking 32 over here. If you want to reduce the points, the space between the points, you can also reduce it in the y axis to make it more clear. So this is our 1 -1, and here our point lies, and here our 1 lies, and here will be. So simply we can erase our the space between 1 and 32. So now you can see that this will be a graph of this kind. We will use one more point order pair to see the direction of graph, and again you can see that we have a negative value in the y as well, that is minus 32. Suppose we have minus 2 over here, so minus 32 in the y-axis will be over here. So now we can join our points to see the graph. It will be of this kind. Let me plot it again. So it will be of this kind. This way you can get an idea of the graphs of power functions. That in this way you can also plot a graph of power function, or you can also see the examples of power function in this figure as well.